Hi everyone, Dennis Foley from AcousticFields. Today we're going to talk about absorption coefficient and Sabins. These are two forms of measurement that we use for sound absorbing products. They're guidelines that we use when we're considering the total amount of absorption inside of a room. They're also guidelines that we use to measure the absorption power, if you will, of a particular technology in a product. But you see these two measurements in the literature quite often, so let's explain them and give some examples of how they work, and I think you'll get a handle on what they actually mean. They're often misused and mislabeled, so hopefully this will help you get a little bit better understanding. Let's deal with absorption coefficient. To determine the absorption coefficient of a product, which is always expressed in percentages, you take a sample size and you inject energy against it from a speaker, and part of that energy goes into the technology or the sample size that's being tested, and part of it is reflected back. So we have absorption into the product, and then we have a percentage of the energy that's reflected back. So in the particular sample size, and you always have to look at this sample size in test results, that absorption coefficient, which is expressed in a percentage, is a ratio of absorbed versus reflected. So if it's a 66% absorption coefficient, then you know that 60% is absorbed and 40% is reflected. So that's the testing procedure and the interpretation of absorption coefficient, which is always expressed in a percentage. Now let's look at Sabins. Okay, we discussed absorption coefficient. Now let's look at Sabins. Sabins is a little bit smaller domain, and we're going to work with just 1 square foot when we're talking about Sabins. So when you see a absorption coefficient data of a particular product expressed in Sabins, you know that you're talking about a domain or a surface area of just 1 square foot. Okay, that's the percentage. The number represents a percentage of absorption in that 1 square foot domain. Okay, a value of 1 is equal to 100% absorption in that particular domain of 1 square foot. So if we have a Sabin value at 50 cycles of 30, we know that in that square foot we have 30 Sabins of absorption going on. So it's a little bit different than absorption coefficient, which is based on a ratio in the sample size. This defines the absorption in the technology that's being sampled and tested in a 1 square foot domain. Similar, but a little bit different. You see some test results that are greater than 1. Well, you can say, well, how can you have more than 100% absorption? Well, you can't. But the value to the right of the decimal point is really due to test bias and edge diffraction errors during the testing procedure. But we don't really consider that to be an issue. We know that a value of 1 or anything larger to the right of the decimal point is 100% of absorption. Another way to think of Sabins is, okay, if we have at 50 cycles, 77 Sabins is our number, which is very high. Then you can use as a rough estimate in your absorption calculations when you're designing rooms. You can say to yourself, okay, well, I have a very powerful absorber, and that represents about 77 square feet of absorption capacity at that particular frequency. So Sabins and absorption coefficient, a little bit different in how they interpret sound absorption data, but both are useful tools in helping you realize the power and the sound absorption capabilities of two different technologies when you're comparing them. If you are going to compare two products from two different manufacturers, Sabins is the number that you really want to look at, because that's the actual amount of absorption per square foot of each technology being sampled. Thank you.